Okay, so just want to do like a really quick explanation of some different examples of how to get your big R, little r, your radius, and your height, whether you're doing washers or shells, um, depending on where your lines are of rotation, where your axis of rotation is at. So I drew the same graph, but just put the line in different places, and some are going to be washers and some are going to be shells. So right here, again, I'm just going to show you guys how to get like your main things, just understand like how to get R and H, because I think that's what people are struggling the most with. So you know that right here, you see how our axis of rotation is over here, and this is we are set up in dx. I set all these up as dx just to use as an example again. Okay, so this is perpendicular, right? So when you have set it up as perpendicular, you know they're gonna do washers. So washers, right? We're gonna have pi big R squared minus R squared. Okay, so what we want is we want to get our big radius minus our little radius. So we want to find our big R and our little r. Right here, we want to get, well, again, what I like to do is I draw like a little circle at the axis of rotation, because that's going to be kind of like the center of a circle, like if your imaginary circle where you're going to be rotating around. And now you want to go and draw a line from there to the outermost function, so the furthest function from that circle. So if you draw a line from here, right, it goes past that first function and touches right here. It touches right there. Right here. So this is going to be your big R. That's your outermost radius, right? Because again, if you were to draw like a, your disc or washer, that's your radius right there. So that's your big R. Your little r is going to be going just from your center to your smaller function, right? So like the one that it touches first. So that's going to be your little r, what touches right here at the blue. Okay. So always go top minus bottom. Top minus bottom, right minus left. Right here, we're doing things top minus bottom because we have this this line right here. This line is the first thing at the top, right? Just look at the way we drew our radius, right? We drew it like this, so we have something at the top and something at the bottom. So we're gonna go top minus bottom. So for big R, right, it's top, which is y equals 4, minus the bottom, which is this curve right here, y equals x squared. So our big R is gonna be 4 minus x squared. That's gonna be our big R. Now for little r, same thing, top minus bottom. So what's the top of the line that we just drew, our little r? Right here, y equals 4. Y equals 4, and then the bottom is this line right here, this function, y equals radical x. So that's gonna be 4 minus radical x. Okay, let's look at another example of washers. So again, we're here perpendicular, right? Because look, we have our rectangle, we set it up like this, right? And the way, I also would have set it up like this anyways in dx, just because we were given our function in terms of x. So it's kind of the easiest thing to do here, right? Because then you don't have to mess with the algebra. You can just use these functions the way they are. That's besides the point though. So we have this dx, and then this is perpendicular. So we're gonna do washers again. So again, we have washer is gonna be pi r squared minus r squared. So we need big R and we need little r. So now we're gonna draw, you see again, look at your axis of rotation. We're right here. This is axis of rotation. So I draw like a circle right here. And I know that I want to go and touch the outermost function. The outermost function is gonna give me the big radius. So if I just draw a line, it goes right past the orange one and touches the blue one. That's your outermost function, right? So if you were to draw a circle, right, it'll look like this. That's the most outermost function. That's your biggest radius. So this is big R. Okay, so your little r would just be from there to the function that it touches first, right? So that the smaller radius, right? So if you draw a little circle right here, so that's what makes your washer, right? I don't know if I did the other one. It'll be like this. It makes your washer, whatever. But okay, so we have our big R and our little r now. We know that this is our little r. We're gonna go top minus bottom again, right? Because we're always gonna go top minus bottom, right minus left. If you were to go right minus left, right? Look, if you go right minus left, there's nothing to the left of it. There's nothing. So you're gonna go top minus bottom. So for big R, right, for this line that we drew big R with, what's the top? The top function is right here, this blue one. That's y equals radical x. That's radical x minus, and then it goes top minus the bottom. What's the bottom? Y equals -2. So it's gonna be minus -2, or square root of x plus 2. Now for your little r, look at the line that you drew for little r. The top is right here, this function, this orange function. which is y equals x squared. So that's going to top x squared minus, you go to the bottom. The bottom is, again, y equals negative squared. So it's going to be minus negative squared. So it's going to be x squared plus 2. Okay. Now, let's look at this version. I set it up so that this would be like doing shells. So, let's see. We have this in terms of dx. Okay, so we know shells is going to be 2 pi RH. 2 pi RH, right? Integral 2 pi RH. So we know we need our radius and our height. We know shells because you see our dx is going up like this, right? This is a rectangle going up vertically, and then this right here, our axis is also vertical, so it's parallel, right? Just like when you write shells, they're parallel, right? We have the two things parallel. So we know we're doing shells. We need our radius and we need our height. So we're rotating around here. So again, I'm going to draw like a little point, like a little circle right here, because that's going to be like our center. Now, our radius, again, like I mentioned before, our radius is going to be just going from your axis of rotation to either the literal variable x or the literal variable y. It's because you're going up to your rectangle. Radius in shells just goes up to your rectangle. When you go up to your rectangle, you're going just to a x value or a y value, because that rectangle could be drawn anywhere. It doesn't matter where you draw it. So it's represented by x or y, by the literal variables. So if you look at our radius, right here, this travels a distance of x, right? Because we're traveling in the x direction, and you're going to go right minus left. So right here is x minus the left right here. X equals negative 2. So our radius is going to be x minus negative 2. And if we're doing shells where things were at the like top and bottom, it would just be, instead of x, it would just be y. So like if you had everything flipped, right? If you had, you're rotating around a line like this, like y equals 2, and then you had your rectangle here at a curve, whatever, it would be, the distance would be, you know, that'll be y distance. So you're literally using just a y variable. Right now we're using the x variable though, because we're going right to left. Okay, so that's our radius. So that's x minus negative 2. That's x plus 2. Our height is just the height of a rectangle. So look at a rectangle. The height is right here. It's represented by this, right? From top minus bottom. Always go top minus bottom, right minus left. The height of it is, it touches this top function first, which is this right here, minus this bottom function, which is this one. So top minus bottom. So it's going to be that blue one minus the orange one. So it's going to be radical x minus x squared. And that's our height. Last example right here, same thing. We're doing shells because we're parallel, right? This is parallel with this. So we're doing shells. So we know we need 2 pi RH. So we need R and we need H. This is the height first. So if we do the height, just look at the height of the rectangle again, right? The height of the rectangle is top minus bottom of your rectangle. So this function minus this function. It's the same as this last one. So it's going to be square root of x, right? That blue minus the orange one. So it's going to be radical x minus x squared. Okay. Now for radius, again, look, draw a little circle and go from here to your rectangle, which is, again, when you're doing radius, every time with shells, radius is represented with x or a y. We're traveling in the x direction. So it's going to be, this is like x right here. Imagine that this dx is like an x. This is just like it goes x amount, because you don't know the actual distance that it's going from your radius, because that rectangle is arbitrary. It could be anywhere. You can place it right here again or right here. It doesn't matter. So that's just x distance. And we're always going to go right minus left. In this case, right, when we went right minus left, we had x minus, right, minus the left right here, this. So it was x minus negative 2. Right here, though, we have the line first on the right, and then we have x here. So we have this line, which is represented by x equals 6. That's on the right. So that's 6 minus, so again, right minus the left. So it's going to be 6 minus x. And there you go. That's just like a basic, how you solve for r and h and little r and big R. All right, everybody. So today in this video, I'm going to show how to find the volume using either the washer disk method or shells with this specific problem from the homework. This problem says we have y equals x squared, y equals 8 radical x, and it's rotated about the y-axis. So the first thing we want to do is just graph these functions, right? So if you don't know these functions right off the bat, how they look, you can always plot some points. So like with y equals x squared, I know that that's a parabola, but if you didn't know that, you can just go on the side and just plot some points. So for instance, when you get 0, right, so when you're looking at y equals x squared right here, you get 0 out. When you plug in 1, you get 1. When you plug in 2, you get 2 squared, so you get 4, and so on. And then you know that also when you plug in -1, you get the same thing out. You get 1. When you plug in -2, you get squared, so then you get +4. So this is just a regular parabola. It's gonna look something like this. Okay. Remember, when you do these problems, they don't have to really be that accurate, the graphs. Try to make them as accurate as possible, but you don't have to plot a bunch of points, as long as you have a rough sketch of the graph. Now, when we look at y equals 8 radical x, for this function, off the bat, I don't know what this looks like. So I'm going to plot some points in for this one too. Notice that we have a radical x right here, right? So you know that inside a radical, you can't plug in negative numbers. So you know that it's only going to be positive numbers going into the x. So I'm going to start with 0. When you plug in 0, you get 0 out. When you plug in 1, you get 8 times the radical 1. 8 times square root 1, so you get 8 back. I'm not going to plug in 2 because if you plug in 2 to the radical, well, you just get radical 2. And, you don't want to deal with numbers that are decimals or fractions. So I'm going to plug in something that I know the square root of, like 4. If I plug in 4, that's going to be 8. Y is equal to 8 radical 4. And that's going to be 8 times 2. So that's 16. This will be something like this. So that's all we really need to know for this one. So you know that I'm going to use different colors. So I'm going to use orange for this one, and this one's pink. So it's going to be 0. And at 1, it goes all the way up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be somewhere like up here. And then at 4, you see that it goes up to 16. So, if we were to keep expanding this graph, it's going to be like somewhere way up here, right? Actually, it should be way higher. Just know that this is a graph that goes up pretty high. Like this. It's a curve, but it just goes up pretty high. Let's keep going. Now, you see how it's not really closed, right? This graph is not closed, and we want it to be closed. Whenever you're given a problem like this, they're always going to be closed so that you have some sort of area, right, that you're trying to get and rotate around. So around something, so you get a volume out. So I know for a fact that they're going to meet somewhere. To check that, you can just use algebra. So you're going to set both of your equations equal to each other. So I'm going to do that on the side. So if we have y equals x squared, and we have y equals 8 radical x, we can set them equal to each other to see at what x value they meet. So I can do x squared equals 8 radical x. We can divide this by 8. X squared over 8 is equal to radical x. And then you can square this on both sides. You get x to the 4th over 64 is equal to x. Then you can multiply times 64. x4 equals 64x. Subtract this. Now you can factor out an x. It's going to give you x cubed minus 64 equals 0. So x equals 0, and you get x cubed minus 64 equals 0. When you solve this one, you get x cubed equals 64. So you have to take the cube root of 64. This is going to give you x is equal to the cube root of 64. So what number times itself 3 times is going to give 64? Well, that's going to be 4. Because 4 times 4 times 4 is 64. So these are going to be your two intercepts. X equals 0 and 4. And you see that they already meet at 0. So that means that somewhere right here at x equals 4, when you go up, they're going to meet somewhere over here, right? So again, you don't have to be super accurate with your graph. Just know that they're going to meet somewhere over here. So we can just, just sketch something like this. Just so we know that they meet over here, right? Again, this is not what the graph actually looks like, but you don't have to be an artist to do this. So just know that they're going to meet here because of your x-intercepts. A lot of the graphs are not going to be this complicated or this, a number like this big, where you have to like draw a graph that goes up to whatever this goes up to in the y value, in the y-axis. You just have to know where they meet. Okay, so we know that they meet here. So they meet at x equals 4 and at x equals 0. Okay. Now, to check what that y value is, just plug it into any of these functions. So, well, at 0, right? So when x equals 0, you know that you have y equals x squared. So when you plug in 0 there, you get y equals 0. So that means that this point is 0, 0 right here. This point is 0, 0. So for the other one, we know that it's at x equals 4. So when you plug in x equals 4, you get y equals 4 squared, right? Because you're plugging into y equals x squared. So you get y equals 16. See, so this point right here is 416. So you don't have to be super accurate, right? You wouldn't actually, I mean, usually you're not going to be drawing a graph that goes up to 16 as the y value. So as long as you know the point though. Okay. So now that we have this, it's all about just your little rectangle, right? So it's all about this guy right here. Either your dx rectangle or your dy rectangle. You get to choose whatever you want, whether you want to use dx or dy. If you forget which is which, just know that your dx, right, means that the thickness of your rectangle, the thickness of your rectangle is going in the x direction. See, it's going in the x direction. This is the thickness of the rectangle is going in the y direction. So this rectangle is dy, this rectangle is dx. So how do you know which you should even try here? Well, look at your functions, right? You have to be a little lazy. Look at these functions right here. I'm given functions in terms of x, right? This is set up for dx. So right away, the first thing I'm going to try is a rectangle that's in the form of dx. So I'm just going to draw a dx rectangle. Because if you're to choose dy, you would have to change these in terms of y, and you'd have to solve these, right? And you don't want to do that. That's just extra work. So right away, I'm going to do dx. So this is a dx rectangle. Okay, and then again, we want to take this. We're considering all this area, but we're getting this dx rectangle. Okay, we're rotating about the y-axis. So this is the y-axis right here. Let me draw this in blue. And so we're rotating around here. This is what we want to rotate around, the y-axis. Okay. Now that we have this, we have to choose, okay, are we doing shells or are we doing washers? All you have to do is compare, again, it's all up to the rectangle. Compare your rectangle to your axis of rotation. So our rectangle is dx, right? This is our rectangle. We have a form of dx. And our axis of rotation is in the y. It's going this way, it's vertical. You see how they're parallel to each other? That means that we're gonna be doing shells, right? And if you forget that, just when you write shells, look, when you write down shells, you see those two L's? Reminds you of the parallel symbol, right? That means parallel, when two things are parallel to each other, like a line and a line, or a rectangle and the y-axis. So just in case you forget that. But yeah, we have parallel, so we're gonna be doing shells. And then for shells, this is gonna be 2 pi RH. So 2 pi times the radius times the height. Okay, first what I'm gonna do is find the height of the rectangle. So the height is gonna be the height of your rectangle, right? So look at your rectangle, look at the height of it. So what does it touch at the top? Right here. You see it's touching this function at the top. It's touching this function, which is y equals 8 radical x. At the bottom, it's touching the pink function. This pink function is y equals x squared. So remember, you're always gonna do top minus bottom or right minus left. If you're doing dx, you can do top minus bottom. So we're gonna get top minus bottom. So we have y equals 8 radical x. So 8 radical x minus x squared. That's gonna be your height. Now for the radius, the good thing about radius for shells is that it's always gonna be involving either just the x variable or just the y variable. Everything we're doing here is in terms of x, right? Because we're in dx. So we're not gonna use the y variable. We know that our radius has to do with the x. We just have to find if it's gonna be x minus something or a number minus x. So you have to look at your radius of the shape that we're making. So we have to look first at, let's look at our axis of rotation. So we're right here, right? This is where we're rotating around, right here. Now to get the radius, you're going from the axis of rotation to your rectangle. So that's why we only have x right here. And you're gonna do right minus left. So this is right here is x. This is x because this whole rectangle is just some arbitrary number, right? This is just x, right? Because we could have drawn it over here. It doesn't matter where it's at. We know this is dx, it's just arbitrary. So we know that the radius is gonna be from x minus here. So x minus 0. Because this y-axis is just on the it's just on the y-axis, the axis of rotation. It's not at x equals 1 or x equals 2. Just as an example, if we had the same graph, so I'll just draw right here. If we had the same exact graph, I'll try to sketch it real quick. Right, and then we had our dx right here, But let's say our axis of rotation was right here at x equals 1. Well, our radius would now be from right to left again, where it will be right here is x, but then right here is 1 at this line. So the radius here will be x minus 1 because you're always going right minus left. The y-axis right here that we have, this is laying at x equals 0. So this is going from x minus 0 right here. So our radius is just going to be x. So now to set it up, you're just going to write 2 pi radius x times the height, which is going to be 8 squared of x minus x squared. We're doing everything in terms of dx. Notice that we don't have any y's in here. So if you have a y in there when you're doing things in terms of dx, you know that you probably did something wrong. You have to go back and change something. And then we know that our bounds, right, we figured out in the beginning was 0 to 4 in the x. So this is going to be from 0 to 4. Okay, I'm not going to do the integration, but that's pretty much how you set it up. Okay, now let's see what happens if we do washer method with this. Okay, so I just copied the same graph that we did. Again, we know that we have these functions, this is what the graph looks like, but now I want to see what are we going to do if we want to do washers. So we know that we have the functions y equals radical x and y equals 8 and y equals 8 radical x. And we know that they go from 0, 0 to 4, 16. Those are like the bounds, the boundaries where they meet at. Okay, so now if you want to do washers, remember, it's not shells where those, those little L's. So it's not parallel. We're actually perpendicular. So we want to have our rectangle be perpendicular to your axis of rotation. Our axis of rotation is right here. It's vertical. So what we're going to do is we're going to draw our rectangle laying down like this. All right, so this is our rectangle. Now when it's laying down like this, right, the thickness of it right here is going up in the y-axis, so it's going to be dy. Okay, so we drew a rectangle perpendicular to your axis of rotation, so we're set up for washers. But notice how we're doing it in terms of dy. So we can't use these functions right now because they're in terms of x, so we have to change them so that they're in terms of y. We have to solve for them. So this y equals radical x, right? We're going to square this. So this becomes x equals y squared. Okay, so now this pink function, instead of y equals x squared, right, it's x equals y squared. Now for y equals 8 radical x, let's see, we can divide by 8. So divide by 8. We have y over 8 equals radical x. Now again, just square it on both sides. So we get x equals y squared over 64. Or x equals 164 times y squared. So that's going to be our orange function right here. So this is going to be x equals 164 y squared. Okay, we're in terms of y now. And then our bounds, we know that we're not using 0 and 4 anymore because we're not using our x bounds. We have to find our y values. So from here to here. Well, we already found that again, remember? So this is 4, 16. So it's going to go, our y bounds, whatever our integral is, right? It's going to go from 0 to 16 because we're not looking at x, now we're in dy. So these are going to be our y bounds. And then we know with washers, we have to do pi big R squared minus R squared. And again, just to reiterate, we're doing everything in dy right now. And it's going to be from 0 to 16. So we have to find big R and little r. So big R is going to be, well, let's look at our axis of rotation. So we're right here. We're right here. Let me get a different color, actually. We're right here. We're right here. Okay. This is our axis of rotation. So imagine that we want to make like a circle, right? That's going to go, it's going to go and touch our outermost radius. So we're going to go over here, right? You see, we're touching right here, right? This is the same thing that your rectangle touches, right? So it touches this function. That's the outermost one. So if you were to draw like a circle, right, that's what they call it, radius, because look, see, that's our big radius because it touches it. This is what it touches on the outside. This is the radius of our circle. So this is going to be our big R right here. Our little r is just going to be the function that it touches on the inside. So the smaller radius right here. So if we go from our axis of rotation to right here, look, it touches this function. So this is little r. This is the smaller radius. So if you draw a smaller circle, right, it will look like this, right? And that makes that washer. That's what that makes that washer. This is a washer, right? It kind of looks like it looks like a disc, but with a hole in it. That's why they're called washers. Okay. So we have our big R and a little r. And again, we're going to go right minus left. So good thing is that our y-axis is centered at the middle, right? So it's not at x equals 1 or x equals 2. It's just going to be right minus left. So it's going to be this function minus 0, and then this function minus 0. So this ping function we have is y squared. So that's going to be our r squared, or our big R. So we're going to have y squared. That's our big R. Our little r is going to be the orange function, which is going to be 164 y squared. So now we need to plug it in into your integral. You can have pi 0 to 16 r squared, which is going to be y squared squared minus 164 y squared squared dy. And then you work that out. Again, I'm not going to take the time to integrate it just because it's going to take a little while, but these are two ways that you can solve this volume problem. Sorry, small mistake. I don't know why I wrote x equals y squared right here. This is y equals x squared. So it should have been x is equal to square root of y, not x equals y squared. So I just accidentally wrote that. That's my bad. So this should be x equals square root of y. And that means that this should be square root of right here. So then inside of here would be square root of y. So that's just a small mistake on my end. But the setup and everything else is still correct, and it's all the same.